What if your daily commute wasn't a chore, but an adventure? Imagine starting your day not in a stuffy, underground tunnel, but on a train that acts like a roller coaster. A train that soars high above bustling streets, leaps across vast rivers, and carves its way along the sides of mountains. Before plunging, impossibly, straight through the side of a residential apartment building. This isn't science fiction. This isn't a theme park ride. This is public transport. You are looking at the most extreme, the most audacious, the most gravity-defying metro system ever conceived. A testament to human engineering built in a city that itself seems to defy logic. But where in the world is this architectural marvel? And what colossal effort did it take to turn this impossible dream into a reality? This is the story of a city known as the Mountain City, a place so vertically complex and mind-bending, it's been nicknamed the 8D City. Welcome to Chongqing.
If you were to visit this Chinese megacity, your first impression would be one of beautiful confusion. It feels unreal. Cities are supposed to be built on flat plains or gentle valleys. It's the sensible thing to do. But Chongqing throws that entire rulebook out the window. It is a city draped across a series of sharp, parallel mountain ranges that slice through the urban landscape like colossal fingers. This isn't a city of gentle hills, it's a concrete jungle of extreme verticality, a place of constant ups and downs, where the concept of ground level is almost meaningless. Stand on a plaza that feels like the street level, and you might be shocked to discover you're actually on the 22nd floor of the building beneath you. One journalist for The Guardian perfectly described it as a cross between the movie Inception and a giant, real-life game of snakes and ladders. It's a place where your GPS gives up, where maps make no sense, and where getting around is a three-dimensional puzzle.
And yet, people live here. A staggering 32 million of them. To put that into perspective, take the entire population of New York City, multiply it by 4, and you're still just shy of the number of people who call Chongqing home. The city's highest points tower some 400 meters above sea level, while its lowest points dip down to around 150 meters. That's a 250-meter vertical difference within the city limits. You could build the Eiffel Tower in the lowest part of Chongqing, and its spire still wouldn't reach the highest neighborhoods. So, in a city built on what seems like impossible terrain, how do you move 32 million people? This is the story of how human ingenuity defied gravity. If you love discovering epic feats of engineering and exploring the world's most incredible places, do us a huge favor and hit that subscribe button and turn on notifications. You are about to witness a journey that will redefine what you think is possible.
Just a few decades ago, the idea of a metro in Chongqing was a fantasy. The city's lifelines were its roads, and they were choking. During rush hour, the streets transformed into a nightmare of gridlock, a chaotic symphony of car horns and frustration. A single road could be clogged with tens of thousands of commuters at once, turning a simple journey into an hours-long ordeal. The situation was so dire that one transportation expert ranked Chongqing's traffic as the second worst in all of China. The city was suffocating under its own weight. It desperately needed a metro to relieve the pressure, to offer a faster, more efficient way to travel. But the very thought of building one here seemed absurd, a technical and financial nightmare. How do you tunnel through solid mountain ranges? How do you build tracks on near vertical slopes? For years, the project was deemed simply too difficult, too expensive, too impossible.
While other major cities like Beijing and Shanghai were developing their subway systems in the 70s and 80s, Chongqing was left behind, a vertical giant shackled by its own geography. But then, in the late 1980s, something changed. A new, determined task force was assembled. This group wasn't interested in why it couldn't be done. They were obsessed with finding out how it could be done. They embarked on a global quest, traveling the world, studying metro systems in other countries, and absorbing every piece of knowledge they could find about building railways in challenging vertical environments. They were hunting for a solution, and they found one.
One of the first and most crucial realizations the task force had was that a traditional, conventional railway system was probably the wrong choice for Chongqing. When we say conventional, We mean the standard two-rail tracks you see in most of the world's subways, from the London Underground to the New York City subway. It's the system China had already used in Beijing and Shanghai. But for Chongqing's unique challenges, they considered a radical alternative: the monorail. Here's why it was a stroke of genius. A straddle beam monorail track is significantly lighter and requires a less bulky structure than a conventional two-rail track. When you're building a metro that needs to be elevated high above the ground on countless bridges and supports, this weight difference is enormous. Fewer, lighter support columns are needed, which dramatically reduces construction complexity and, crucially, cost. The task force calculated that building a conventional metro here would cost a staggering $200 million for every single kilometer of track. But a monorail system? It would cost half that, around $100 million per kilometer. The savings were astronomical, but the benefits didn't stop there. Monorails are quieter and more energy efficient. The task force estimated a conventional station would consume 10 times more energy than a monorail station. They are also incredibly agile. Monorails can handle much tighter turns and climb far steeper gradients than conventional trains. Two abilities that were absolutely essential in a city that twists and climbs like Chongqing. For this vertical city, the monorail wasn't just an option. It was a no-brainer. You might be wondering, if monorails are this great, why isn't every city using them? The truth is, a monorail's advantages shine brightest when you're building an elevated system. For underground systems, it's a different story. While a monorail track is lighter, its single tall beam actually takes up more vertical space than two low, flat rails. If you're digging tunnels, you want the smallest possible profile to save time and money on excavation. A tall monorail system would require digging bigger, more expensive tunnels. So, in most cities, which rely heavily on tunneling, monorails are the less practical choice. But not in Chongqing. In this 8D city, where the plan was to soar above the landscape as much as burrow through it, the monorail made perfect sense. The project was officially greenlit, but the challenges were far from over. Normally, to build an elevated railway, you'd erect the support columns and then use massive cranes to lift and lower each section of track into place. But in Chongqing's dense, narrow, and sloping urban environment, there was often no room for these giant cranes to operate. Moving around as a person was hard enough, let alone maneuvering heavy construction equipment. So, the engineers had to innovate once again. They designed and built a specialized piece of machinery, a custom beam transport machine. This ingenious device would cradle a massive concrete monorail beam under its belly, slowly crawl out onto the already laid support columns, and then carefully lower the next section of the track into place, piece by piece, like a giant mechanical caterpillar, spinning a web of concrete and steel across the city. In December of 2000, these incredible machines roared to life, and construction began. After decades of dreaming, the impossible was finally happening. Just 5 years later, in 2005, the first line of the Chongqing Rail Transit officially opened its doors to the public. And this very first line, Line 2, is the one that contains perhaps the metro's most famous feature: the train that runs through a building. The story behind it is a perfect example of Chongqing's unique approach to urban planning. When the route for Line 2 was being designed, this specific piece of land was already owned by property developers who planned to build a residential apartment block right there. It was a classic conflict: immovable infrastructure versus an immovable building. In any other city, this would have resulted in lengthy legal battles or a costly reroute. But here, they chose a third option: collaboration. The metro planners and the building architects worked together to design a structure that could coexist. A building with a transit station literally integrated into its 6th, 7th, and 8th floors. To pull this off, they had to solve a major problem: vibrations and noise. They engineered a brilliant solution. The monorail track doesn't actually touch the main structure of the building. It rests on its own independent pillars, which are housed inside wide, hollow tubes built into the building's framework. This gap ensures that when a train rumbles through, the vibrations from the pillars don't transfer to the residential floors. And what about the noise for the residents? Well, monorails are naturally much quieter than steel-on-steel conventional trains. For those living in the apartments, the sound of a passing train is about 60 decibels, roughly the same as a modern dishwasher. A minor, rhythmic hum in exchange for having a metro station right in your own building.
But this was just the beginning. After the success of the first monorail line, the construction teams kept going, expanding the network at a breathtaking pace. A second monorail line, Line 3, was completed a few years later. This line alone is a world beater. At over 67 kilometers, it is the single longest and busiest monorail line on the entire planet, carrying around 250 million passengers every year. And the network kept growing. Today, there are 12 lines in total, with more under construction. Interestingly, after the first two pioneering monorail lines, the city began incorporating conventional rail lines as well. Planners realized that this up-and-down city needed a hybrid approach, a combination of elevated monorails to soar over the landscape and conventional heavy rail subways to tunnel deep through the mountains. This has resulted in the unique mixed network we see today, a system that has shattered world records in the process. Chongqing is home to Hualongqiao Station, the highest metro station in the world, with its platform suspended an incredible 50 meters above the ground, like waiting for a train on the roof of a 15-story building. But believe it or not, the same city is also home to Hongyankan Station, the deepest subway station in the world. At its lowest point, its platforms lie more than 100 meters beneath the surface. That's deeper than the Statue of Liberty is tall. It takes a full 8 minutes just to ride the series of escalators down to the platform, and locals say your ears pop on the way down, just like in an airplane. The most mind-boggling fact of all? These two stations, the world's highest and the world's deepest, are on the exact same metro line, just a few stops apart. And the records don't stop there. The city's metro relies on some of the most impressive bridges ever built for public transit. There's the Yigongyan Rail Transit Bridge, a 1.6 kilometer long behemoth that holds the record for the longest metro-only suspension bridge in the world. Then there's the Kaija Rail Transit Bridge, which carries trains 100 meters above the Jialing River, making it the highest metro-only bridge on Earth. On misty days, when the city's famous fog rolls in, crossing this bridge feels like riding a train directly through the clouds, a surreal journey through the heavens. And we can't forget the Kaohsiunmun Bridge, a colossal steel structure that holds the world record for the longest through-arch bridge, surpassing even the famous Sydney Harbour Bridge in its scale. It's an unparalleled collection of engineering marvels. The single station of Hongyankan, the world's deepest, took 3 grueling years to build. By the end of its construction, it took each worker nearly 20 minutes to descend into the worksite at the start of their shift, and another 20 minutes to climb back out at the end of the day. Yet, just like with the monorails, the city got it done. And the story is far from over. The ambition is relentless. By 2035, the plan is to have a total of 23 rail lines, nearly doubling the current network. We can only imagine what new records they will break, what new engineering challenges they will conquer. It's truly incredible to think that for millions of people, this is not a tourist attraction. This is their daily life. This is their commute. The Chongqing Metro is more than just a transportation system. It's a symbol. It's a bold declaration that with enough ingenuity, determination, and creative thinking, humanity can tame even the most formidable landscapes. It's a reminder that sometimes, the most audacious and seemingly impossible ideas are the ones that change the world. It is, without a doubt, the most extreme metro ever built.